Yo, what's up? Time for another summary video, guys. Smash that subscribe button and the like. Don't forget the like as well. Um, but yeah, I mean, here we go. I'll just do a summary of what's been happening this week. Yeah, the Church of What's Happening. Desktop and webcam. Very good podcast. The Church of What's Happening Now. Anyway, with Joey Diaz. Okay, so essentially this week wasn't not too much stuff happened. Basically, I was just testing out the enemy creator kind of system that I set up last week. So just testing that this works. So I've got 3 different enemy types here: Spline Mover Pig, different sprite, test 2. Lovely name there. And then we've got a data handler thing here. I thought you could just have scriptable objects in the assets section. I didn't realize you actually had to create a thing. But yeah, we find out more about scriptable objects, like when you have where is it, create or something. Yeah, create. So here we go. Enemy configurations, keyword set, or data handler. So I found out you can create little menus here in this sub menu of creating stuff, which is cool. Scriptable objects are pretty damn cool, I can't lie. I've never really used them before. I just used the basic game objects, but they are pretty handy, and you can just have like some data with them and also have some functionality if you want, which is pretty darn gnarly. So yeah, so basically we tested it out. I can show you what I mean. So enemies, data, my data types. So as you can see, different sprite just has the default sprite. This has a pig sprite, which, and then this is a spline mover. So if I press play, it'll spawn in, and the enemy controller will spawn in an enemy with a random one of these. What's the word, like prefabs, I guess. I don't know. A random one of these set of keywords. So I press play. Let's see what happens. Oh, is it gonna run? Is it gonna? Yes, it is. Boom. So I'll pause this. We'll see what. So enemy clone. So as you can see, it's got a sprite renderer just with the scrolling background. I just put in like a random sprite to test it. So I think that's like this one different sprite. So that was a random one. If I try it again, it'll be random, so it could be the same one, but we'll see what happens. This time it's got the sprite renderer, but it's a different sprite. So if I zoom in on the clone, okay, well it's behind this, but if I move it, it's a pig sprite. Don't know what's that coming over the hill. Is it a pig sprite? It's a pig sprite, yeah. So that means that is this second one, which is called Spline Mover Pig. Yeah. So it just uses a random one of these. I'll keep playing it until we get the final one. So essentially, yeah. So on the previous 2, added a renderer, and oh wow, dude, what lucky days! It chose a different one each time. Damn, I'm feeling lucky today. So this time it added a script instead of the spline mover, instead of the thing. Very helpful. But yeah, so as you can see, it's just invisible. Basically, it doesn't actually have a sprite renderer, and instead has this script, which is this one. Yeah, spline mover. So it just adds. So it's test 2. Yeah, so I was testing that out. So obviously you can see that works. And the second thing I did was I started implementing a swarm-based movement system. So here we go. Hopefully Visual Studio doesn't take too long to load here. I can show you what's crack-a-lacking, my friends. My best friendo. Great anime quote, that one. That's from JoJo's Bizarre Adventure. If you haven't seen it, very good show. From the peak character Avdol. He's got a fire ability, just like this fiery bird. Yeah, so okay, that's the controller. Swarm movement. Okay, well it's called something different now, so let's go back in here, open it up. Swarm agents. Boom. So here we have our swarm agent. Our agent of the swarm. That's like a Marvel thing, isn't it? I don't know. No, agent, I don't know, who cares? Yeah. So essentially with swarm agent, if I'll open up paint here. So this is, it's kind of like movement for if I've got like a bunch of different different kind of enemies like this, they'll all kind of move as a swarm together. So I'll open up the script again. As you can see, I've got cohesion, separation, and alignment. Essentially, yeah. So cohesion, separation, and alignment. Essentially, what cohesion is cohesion is essentially like is essentially okay. So is essentially the distance from like this agent. Okay, so how about we'll say this is the agent we're looking at. So cohesion is the distance from this to the center of mass of the swarm. So that would be around here. If it's if we're talking about this being the swarm. So for example, yeah, we'll say we're focusing on this agent. Its detection radius is this. So all of these are determined in the same swarm. But you can see they're all kind of clumped together, like, see if I can move this. They're all kind of clumped together here. So the center of mass would essentially be like, yeah, right in the middle here. So cohesion is the direction from this to the center. Separation is separation of neighbors, alignment factor. Let's take a look. Minus agent position, avoid vector. Yeah, so separation is like the distance between them, between each individual agent here. And then we have alignment, which is okay, because basically we're saying that each one of these swarm agents are going to be moving in a slightly different direction, and alignment is basically which general direction are they moving in. So we could say the swarm as a whole is moving in this direction or something. Green as go. Let's do green. So the swarm as a whole is moving in this direction. Obviously, the center of the swarm is over here. So this will start heading towards the center. But also you have the separation between this and the rest of the swarm. So that would also play a factor. Let me just double check what I did with separation here. Avoid vector for each agent in neighbors. Difference is transform minus the other one. Avoid vector plus equals. Okay, I remember. So basically, you don't want this hitting into the other swarm members. So for example, the vector from here to here is going to be cut off, and so is the one from here to here. So it'll avoid all of these directions that are directly in the path of another agent. Okay, I probably should have started with how I'm approaching this in the first place. So, okay, swarm movement. So essentially, each agent moves, determines which direction to move in based on 3 factors. And those factors are the ones I mentioned a minute ago: cohesion, separation, and alignment. Yeah. So I mean, I've explained each of them. So essentially, the direction that this will go in is going to be a combination of going towards the center, going towards the general direction the swarm is going in, and also away from colliding with the others. So the combination of those 3 vectors is going to be the direction that this agent moves in. So as you can see here, maybe if I do this, make it a little, make it make sense, gal. Make it make sense. We'll make it make a little more sense. Hopefully this explanation is fairly coherent or cohesive. I do make myself chuckle sometimes. Right. So yeah, so you can see, yeah, cohesion, separation, alignment. So cohesion towards the center, alignment towards the general direction of the swarm, and separation away from all these other nasty agents. You don't want to collide with any of them now, do you? Yeah. So we got our list of swarm agents, and also, yeah, of course, we've got our detection radius, which is this. Well, it would be this. It'd be this outer bigger circle, which all of these are in. So, yeah. So, as you can see, neighbors is the amount of neighbors. Get neighbors here. Find objects, swarm agent. So this is just all of them in the scene. If I want it to be, oh yeah, no, I have done that. Okay, yeah. So gets all the swarm agents, checks if they're in the detection radius of the specific one we're looking at. If it is, then it'll add it to the list of neighbors. Cohesion, yeah. So we've got our cohesion, which is this neighbors times cohesion factor. So as you can see, center of mass. So center of mass starts at 0, and then it gets each position of each one of these, and just finds the average of the center of all of them here. And yeah, obviously, if there's no neighbors, if it's just this one on its own, then it'll do its own thing. But yeah, and then so the center of mass, yeah, so this is just the average center of mass divided by each one of them, which is just the average here, and then it just returns it. And then we normalize it as well, because we want to normalize the vector between this and that. We don't want it, we just want it like a slight influence. We just want to determine which general direction to go into. So, I mean, I'm sure you guys know what normalized means, but normalized just means like a unit vector. So it's just using like, I don't know, like one or 0 mainly. Like, well, 1 0 would be this, or it's a value between 0 and 1 basically. So it's like a very small vector that just is used to show the general kind of scale of them. That's what normalized means. I'm sure you guys know what normalized means if you're watching a game development video. But yeah, so we've got separation of the neighbors, which is just avoid. Yeah, so this is avoid vector, the vector to avoid, which basically finds the difference in the positions between this and the others, and then yeah, squares. So it squares the avoid vector equals difference divided by difference of square magnitude. So yeah, so it just finds the difference between each of the positions, and then it's like, oh, we don't want to hit into any of those, and then it normalizes that as well, and then the same with alignment. So heading, which is the thing it's heading towards, just this big green arrow here, and then for each agent in the neighbors, it will add the current, so it will find the velocity it's currently going towards. So that one's starting going over here, that one's going there, and then overall averages out to this big direction here, and then yeah, gets the average direction they're heading towards and normalizes it. Simple. And yeah, so also I was thinking about doing a general, like, for example, this is just a very general swarm based AI, but if I need to like have a specific target that I want the swarm to move towards, I was thinking about how I might want to implement that, and I don't think it wouldn't be too difficult. I just need to just basically change the final velocity. Oh yeah, so yeah, change the final velocity. So at the moment it's just cohesion plus separation plus alignment. So if I'm having a specific target, I'd probably do all the calculations, figure out what that target is, and then add it in here. Yeah, job's a good one. So I think I think that was basically all I managed to achieve this on the stream the other day. So yeah, I mean, holla at your boy, you know. Fucking like and subscribe, as I said. Follow the Twitch down below. And yeah, I usually stream. Well, it's a little incoherent at the moment, but I'm probably gonna start like streaming, or try to stream every day, if not every other day. I'm gonna get really into this. So you know, tune in for that. But if not, then it will be like Mondays, Mondays or Wednesdays usually. But yeah, peace out. Have a good one. Have a good day. Ciao.